Okay, so today we're going to go through the January 2019 iGCSE Edexcel Paper 2H. Let's get going. So, a plane has length 73 metres. The scale model is made of the plane. The scale of the model is 1 to 200. Work out the length of the scale model. Give your answer in centimetres. So we've got a scale of 1 to 200. That means we've got, if it's in the model, and then we've got the real world, and that is in the ratio 1 to 200. And we know that we've got 73 metres in the real world, so we need to turn that into centimetres. There are 100 centimetres, so that's 7300. Okay, so we need to work out what we've got to times by that. So to work out what you've got to times, 300 divided by 200 is 36.5. So that's what you've got to times by. So the model you've got to times by 36.5. So 36.5 73,000. So how big is it? It's 36.5. Okay, here are the first 5 terms of an arithmetic sequence. So write down the nth term for this sequence. So the nth term is, how do you get any term? Well, you can see that it's going up in 4s each time. So 4n would be 4, 8, 12, 16, 20. And you can see that this is 3 bigger than that. So this is 4n plus 3 is 7, 11, 15, 19, 23, etc. So answer is 4n plus 3. Okay, there are 90 counters in a bag. Each counter in the bag is either red or blue. So the number of red counters and the number of blue counters is 2 to 13. So divide it in the ratio 2 to 13. Red to blue. Got a total 15. We know that the total is 90. So how many times bigger? Well, that's 90 divided by 15, which is 6. So I've got to times this by 6. That's 12. This by 6. That's 678. Check those that up. Yep, so I've got 12 red and 78 blue. Lai is going to put some more red counters in the bag, so that the probability of taking a random red counter from the bag is 1 over 3. So we're going to add a number of red to this bag, and we want 12 plus the number that we're going to add. We don't know, so let's call it x, over the total number now in the bag is 90 plus x, and that has to equal 1/3. So the fraction equals 1/3. So I'm then going to multiply both sides by 90 plus x. So let's just, so 12 plus x equals 1/3 times 90 plus x. Then I'm going to multiply both sides by 3 to get rid of the third, so that gets rid of the division there. And then I'm going to multiply by 3. So I get 3 lots of 12 plus x equals 3 lots of this side is just 90 plus x. So I get 36 plus 3x equals 90 plus x. Take x off both sides, I get 3x plus 2x equals 90, 2x equals 36, take away 36 from both sides, 30, 60, 54, so x equals 27. So what was the question? What is the number of reds? Well, it's just 27. There we go. So the second bit of that is a little bit harder, but the first bit interestingly gets you 2 marks, so well worth giving that a go. You get the first bits. Okay, Venn diagram. So we need to know some of this terminology. That little E there at the beginning, that's the universal set. This is A has all the odd numbers. A intersection, so that little N means intersection of the things that overlap. A union B, that's everything in A or B or both. So that's A, and that's B, and it tells us that the intersection is 1 and 3, so let's put those in. Then says A is all the odd numbers. So we've got all the odd numbers, but not 1 and 3 because they're already there. So 1, 3, 5, 7, 9, 11, and it stops at 12. It's fine. So B is 1 and 3. There's also 2 in there. There's also 4 in there. 5, 6, 7, no 8, so 8's got to be outside, 9, 10, outside 11, and 12. So there we go. So we've got all the numbers 1 to 12 in the box. A is only odd numbers. B is the things that aren't in A but are in that A union B, and 8 and 10 are everything else. There we go. Okay, question 5. Calvin has 12 identical rectangle tiles. He arranges them to fit exactly around the edges shown. Work out the area of the shaded region. Okay, so again, we're not quite sure, but we know that if I go that the width is x, so from there to there, then from there to there is also x. So the area is 123 minus 2x times 67 minus 2x. So I've got to work out what that is. So we need to work out what x is. Now we also know that the length we know that 2 lots of the length plus x, so if this is the length that I don't know, 2 lots of the length plus x is 67, and we know 1, 2, 3, 4 lots of the length plus x equals 123. So I'm going to subtract these. These look like simultaneous equations. I'm going to do the bottom one, take away the top one. I'm going to get 2l, and then I've got 123 minus 67 is 56. So I know the length is 28. So then I know that 2 times 28 plus something equals 67. Subbing that back into the top one. So I've got 56 here. So I make x 67 minus 56 is 11. So I think I can now work out the area. So the area equals 123 minus 22 times 67 minus 22, which equals 4545. So a little bit of algebra involved, but actually doable. Okay, next one. Find the highest common factor of 96 and 120. So 96 is 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. And then 120 is 2 and 60, which is 2 and 30, which is 2 and 15, which is 2 and 5, which is 3 and 5. So the highest common factor. So we've got a 2 and a 2, a 2 and a 2, 2 and a 2, so far we've got 3 2's that are in common, and a 3. They're the only things in common. So the highest common factor is 2 times 2 times 2 times 3, which is 24. The highest number that goes into both of those. Find the lowest common multiple. So the lowest common multiple has to be a multiple of all these things. So it's actually the highest number of all of these. So it's 2 to the 4 times a 3 times the highest number of 5's, which is 5 squared, highest number of 7's, which is 7 squareds, times an 11. Work that out. We get the massive 6, 4, 6, 8, 0, 0. Okay, Jenny invests $87,000 for 3 years in a savings account. She gets 2.3% per year compound interest. How much money will Jenny have in her savings? So 8500 divided by 100 times it by 2.3 is $195.5. So after 1 year, it's add that on. So you've got after 1 year 8695.5, and then we're going to divide that by 100 times it by 2.3. Is 199.9965. We can add that. We get 8869.4965. So that's after 1 year. So after 2 years. by 100 times by okay, and I'm going to add on the 8,869,965. Is 9073. That's after 3 years. But there's a quicker way that should give us the same answer. 8500, and you times by 1.023. It's 100% plus 2.3%. You do that 3 times, so that's to the power 3. That equals 0.09292, and they want it to the nearest dollar, so that's 9100. Okay, let's just go back and check where I've made a mistake, because clearly I have. Oh dear, 8695.5 right at the beginning. 8695.5. Dear me. Okay. So apologies, let's check that again. Eight, 6, 9, 95.5. $199.9965. Add that on. 695.5 is 8895.465. Divide that by 100 times by 2.3. 204.5964,195. Add that on to 8895.4965. 9100.09292, which is as we got before. So there we go, to the nearest dollar, 1900. Okay, Rami bought a house on the 1st of January 2015. The house increased in value by 15%. 2016, the house decreased in value by 8%. On the 1st of January 2017, the value of the house was. So we go back in time. So we got 2015, 2016, 2017. And this is the price here, 68700. So the first loop, let's work out what it was this time. So it's always the valuation is always done in original. So if this was the 100%, then it's decreased by 8%. So this is 92%. Okay, see what I've done there? The original price, 2016, is 100. So this is 92. So I've got to work out what 1% is. Is 68700 divided by 92, and then I've got to times that by 100 to get 100%. So that's 74673.913. And then now I've got to go back again. So now this one is the 100%, and it's increased. So this is 115%. It's increased by 15. So I'm now going to divide this answer by 115 and times that by 100. And we get 64933,837. Let's written this down. 700. Okay. So let's use the right numbers this time. 687,700 divided by 92 times by 100 is 7. And this time, this is 2015, we're now considering 100%. This one's going to be 115%. So I'm going to divide by 115 times by 100. We get 650,000. There we go. A block of wood has mass of this, and the wood has density this. Okay, so density is kilograms per meter cubed. So density is the mass over the volume. So this works a bit like the trig one. We're now trying to work out the volume. So the volume is the mass over the density. Volume equals mass over density. Mass is 3.5, density is 0.65. 3.5 divided by 0.65 is 5.3846. 5.38 meters cubed. Okay, change the speed of 630 kilometers per hour. So firstly, the easiest one to change is the meters. We're trying to get into meters per second. So it's 630 meters, there are 1,000, another 30 meters per hour. So it goes 1,000 times more meters. And then we've got a meters per minute. So we're going to divide by 60. 630 divided by 60 meters per, this is now minute, because there's 60 minutes now, then 630,000 divided by 60, divided by 60 again, is meters per second. 630,000 divided by is 175 meters per second. Okay, solve the simultaneous equation. So we want the same number of y's or the same number of x's. So I'm going to get the same number of x's, because if I double the bottom one, I'm going to get 4x minus 2y equals 18. Now, I've got 4x plus 5y equals 4. So I'm going to take these away. So if I do 4x, take away 4x, I get no x. Then I've got to be careful. 5x minus 2x, that is 7y. 4 minus 18 minus 14. Divide by 7, y equals minus 2. Put that back into the top equation. 4x plus 5 times minus 2 equals 4. It is 4x minus 10 equals 4. 4x, add 10 to both sides, is 14. So x divided by 4 is 3.5. So x is 3.5. Y is minus 2. I can check that both of these equations. 3.5 times 4 minus 10 is 4. 2 times 3.5 is 7. Minus 2 is plus 2, which is 9. So tick, I know I've got those 3 marks. Very good. Okay, the line is drawn. Find the equation of the line. So, the thing we need to remember, equation of a straight line is y is mx plus c, where this is the gradient and this is the y-intercept. So the gradient is the rise over the run. So I'm going to go from a point that I've plotted to another point that I can see. So the rise is 3 and the run is 2. So the gradient is 3 over 2, 1.5. And then the c is where it crosses the y-axis, which is at 1. So very simply, y equals 1.5x plus 1, or 3 over 2x, or y equals 3 over 2x plus 1. Either of those are legitimate. Okay, 20 students took out a science and maths test. Both tests marked at a 50. The table gives the information. So science and maths are the median. So the median is kind of where the middle person is. So where the middle person in the set in science is at 27 and maths is in 24. So the median is higher for maths, for science. So generally, state the obvious, people did better in science. Okay, so that's commented on this bit. Then we've got the interquartile range. The interquartile range is higher for science, so results are more spread out. There's more variation between the results, they're more spread out, a higher interquartile range. Okay. Technically it should say the middle 50%. But there we go, so simplify n to the naught. Well, I don't know whether any of you tried putting the power to the naught in your calculator. Whatever number you choose, it will always give you 1. Okay, this is cubed, so this is 3x squared y to the 5 times 3x squared y to the 5 times x squared y to the 5. So now 3 times 3 times 3, that's 27. X squared times x squared times x squared. How many x's are there? 6 to the 6. Y, how many y's are there? There's 15 y's there. Okay. Fully factorise. So 2 terms, we start off with this and we go, okay, we're going to take a 2 out because 2 goes into both of those. 2e squared minus 9 gets 1 mark, unfortunately. This is another stage of factorising, and this is a special factorising. It's called the difference of 2 squares because we've got a square number here, and it becomes 2e minus 3, e plus 3. If we just multiply that out, just to check, e minus 3 plus 3, we've got e squared minus 3e, minus 3e plus 3e minus 9. Okay, which is what we want, e squared, 3e's cancel, minus 9. So that is our answer. Okay, make r the subject. Well, we've got a square root and a fraction, and they are in 2 places. So reasonably tricky, but let's give it a go. First thing, we're going to square both sides. M squared equals 6a plus r over 5r. Then we're going to get rid of the fraction. 5r times both sides by 5r. So 5r m squared equals 6a plus r. Move the r's onto both sides, so we get 5r m squared minus r from both sides equals 6a, minus r from this side, and it goes. And then I've got 5r and r, so I'm going to have to take r out as a factor, and I get 5m squared minus 1 equals 6a. Get r on its own, divide by that, I get 6a over 5m squared minus 1. There you go. Okay, 13. The frequency table gives the information about the number of mice in some nests. The mean number. So the mean number, we've got to do the frequencies times the number of mice. So that's 20. 6 times 13 is 60, 70. 78. 7 times 16, I can't do in my head. 112. 8 times x. Well, we know that's just 8x. Don't worry about it for now, but it is. 9 times 6 is 54. And we know that 20 plus 78 plus 12x, plus 112 plus 8x plus 54 divided by how many there are. Well, there's 4 plus 13 plus 16 plus x plus 6 is 39 plus x, and that's got to equal 7. So again, if I multiply the bottom by that, 20 plus 78 plus 112 plus 8x plus 54 equals 7 lots of 39 plus x. See, this has come up several times already, this paper, multiplying out by the bottom fraction. So I collect together all the numbers. 20 plus 78 plus 112 plus 54 is 264 plus 8x equals 7 lots of 39, 273 plus 7x. Okay, so I'm going to take 7x off both sides. I get 264 plus x equals 273. Take 264 off both sides. Get x equals 273, 6, 7, 8, 9. X equals 9. All good. Okay. Marcus plays 2 games of tennis. For each game, the probability that Marcus wins is 0.3. For each game, the probability wins that Marcus is 0.3. So, if Marcus wins, Marcus wins. If he doesn't win, he loses. So you get 0.65, 0.65, 0.3, he wins, 0.65. So sometimes this will change, but this one it tells us for each game. Work out the probability that Marcus wins at least one of the 2 games. So he wins, he wins at least one. He wins and he loses, he wins at least one. Doesn't win and has to win. So we want all these paths. So this is 0.65 times 0.3, 0.35 times 0.65, 0.35 times 0.35. We add those together, 0.35 times 0.35 plus 0.35 times 0.65 is 0.65 times 0.3. Add those all together and I get 0.35, sorry. So I should probably write that all out. 0.35 times 0.35 plus 0.35 times 0.65 plus 0.65 times 0.35. Add that all together, it comes 0.5775. Okay, the diagram shows a trapezium. All the measurements shown in the diagram are centimetres. Show that the area of the trapezium is 133. Show that this is true. Well, we know that the area equals half A plus B times H, and that comes from the formula book on the front of the worksheet. So we know the area is 133. We know that equals a half A, that's the top length, x plus 5, plus the bottom length, 3x minus 2, times h, which is 2x minus 3, times by half equals 133. So I'm going to multiply both sides up by 2 to get rid of that fraction. 266 equals x plus 5 plus x, that's 4x plus 3, 2x minus 3. So I'm going to multiply out these brackets. 4x plus 3, 2x minus 3, so it's 8x squared plus 6x minus 12x minus 9. That's 266 equals 8x squared. And we've got minus 6x's altogether, minus 9. So we've got a minus 266 from both sides. And we get 0 equals 8x squared. 6x minus 275. Find the value of x. Now, I am going to use the formula because I think it's just easier when you've got big numbers like this. The formula says x equals minus b, it's on the formula sheet, plus or minus the square root of b squared minus 4ac over 2a. And this is a, this is b, this is c. So I put in x is minus 6 plus or minus the square root minus 6 squared is 4 times 8 times minus 275 all over 2 times 8. X equals 5.5. Now I'm going to run the same thing but with a minus sign in it, and I think it will come to a negative number. Minus 25.4, which is not. It says it's got to be a positive number. So there we go. There's the value of wrong. Minus 6, that's plus 6. Over 4, sorry, my fault. 25 over 4, or 6.25. The other one is minus 11 over 2, so it's not that one. Okay. Okay, question 16. Diagram shows two mathematically similar, so we're getting onto some tricky questions here, mathematically similar. So we want to know the volume, how many times bigger? Well, it's that many times bigger. So the thing is, we want to get the ratio of the lengths, so we need to cube root it. So we've got the cube root of 960 divided by 405 is 4 over 3. And then the ratio of the, so this is lengths, so areas is that squared. Is 16 over 9. So what we're saying is that to get from B to A, you have to divide by 4 over 3. So in this you have to do 928 divided by 16 over 9. Is 5 have it. Function, work out f5. So 5 means where there was an x, put a 5. So you've got f of 5 equals 4 minus 3 times 5. 4 minus 15, which is minus 11. Okay. G is the function such that 1 over 1 minus 2x. Find the value that cannot be included in the domain. So what value, when I put it in here, will give error on the calculator? Well, if this bottom is 0, that will give error. So 1 minus 2x equaling 0. Add 2x to both sides. 1 equals 2x. Implies x equals 1/2. So that's the area where we've got an issue. Then says work out f of g of 1.5. So that means f of g of this is 1 over 1 minus 2 times 1 over f of 1 over 1 plus 3 is f of a quarter. Put a quarter in to f, so that means f of a quarter is 4 minus 3 times a quarter. So 4 minus 3 times a quarter is 3.25. There we go. Okay. Question 18. So we want the smallest bound, the lower bound of P. So to make P small, we need a small top, so that needs to be small. We need a big bottom, so that needs to be big, that needs to be small. Okay, so we're going to go big A, lower bound P. Big A, what's the biggest A can be? Well, that's correct, one significant figure, so the biggest it can be is 8.5. M, correct to the nearest 10. Smallest, sorry, I've got that wrong. So, sorry, I want the lower bound, so I want the smallest on the top. 7.5. Then we want the biggest M, so that's 25. Take away the smallest X, so that's two significant figures, so 4, smallest X, 4.55. Okay, if you don't know about bounds and why I've done the 0.5 either side or the 5 either side, then you will need to go and look that up. Is letters the wrong way around. Sorry. So A is on top I want a small a, so that's 4.55. I want a large m, so that's 25, minus a small x, so that's 7.5. Let's try that again. That's a bit better, 0.26. Okay. Let's keep going. Histogram. Work out a proportion of these who waited longer than 20 minutes. Proportion. Okay. Histogram, area equals frequency. So there's 20. So the area above equals, well, is 20 to 30, so that's 10 times, how high is it? According to the scale here, it's 1 high. The area above is 10. The area below is lots of different bits. Or actually we want the area in total. So we've got this rectangle at the bottom, so equals 15 times 1 plus 5 times 2.2 plus 5 times 3.4 plus 2 times 2.5 plus 3 times 4. Altogether, is 60. So what is the fraction? Well, it's 10 over 60, which is 1/6. There we go. Okay, number 20. Angle BCQ is x. Got a tangent, points on the circle. AB is BC. Prove that angle CDA is 2x. Well, if I've got this, then I'm thinking alternate segment theorem, but alternate segment theorem needs a triangle. So I'm going to have to draw this in to get a triangle. I'm just going to start by doing something. And if I've got that as a triangle, then that is going to be x. And then this is an isosceles triangle, so this is going to be x as well. So then this is going to be 180 minus 2x. And then the other one, ADC, is 180 minus 180 minus 2x, which is 180 minus 180 plus 2x. That's just 2x. And I should say, give reasons for the angle, so let's put this in angle CAB by the alternate segment theorem. And then angle ACB equals x. That's base angles and isosceles triangle are equal in isosceles triangle equal, and this last one is opposite angles in cyclic quadrilateral add up to 180. There we go, and I've not written that very nicely, but you can see what's going on hopefully. Okay, let's keep going forward. L has equation 4y minus 6x equals 33. Line M goes through the point this and the point this. Line L is perpendicular to M. Work out the value of K. So 4y minus 6x is 33. So let's just get this in the form y equals, because that's much nicer. So 4y equals, add 6x to both sides, 6x plus 33. Then you're going to divide by 4. Equals 6 over 4x plus 33 over 4. And then M is perpendicular to L. So this is L. So the gradient is minus 1 over it. So it's minus, turn it upside down, minus 4 over 6. So then we're going to get this new line has to go through the point 5, 6. So it's y equals minus 4 over 6 x plus something. Put the numbers in, so you've got x is 5 and y is 6. So 6 equals minus 4 over 6 times 5 plus c. So 6 plus 20 over 6. C is 28 over 3. So our equation y equals minus 4 over 6x plus 28 over 3. That's not very nice numbers. So we're now going to have to work out when x is minus 4, y equals minus 4 over 6 x, which is minus 4, plus 28 over 3. Plug all that in. And you get y is 12. Okay, reasonably involved, but we've got there. Okay, number 22. So penultimate question. AB is the diameter of a cone, V is the vertex of the cone. Given that the area of the base of the cone to the total surface area of the cone is 3 to x, work out the size of angle AVB. Wow. Okay, so not sure where we're going here, but let's just label some things on the diagram. Let's call that R. Let's call that H. And we'll call that L. So we've got the area of the base, pi r squared, to the total surface area of the cone. So that's pi r squared plus pi r L. That is the ratio 3 to 8. that pi r squared divided by 3 equals pi r squared plus pi rl divided by 8. So we can actually, we've got pi, we divide everything by pi, we can actually divide everything by by r. So we're left with r over 3 equals r plus l over 8. So I'm going to get 8r equals 3r plus 3l. So I get 5r equals L. So I'm going to get L equals 5R over 3. And that means that now I want to get the angle AVB. So I'm going to get this one, which is half of it. I'm going to do that by a bit of this is the hypotenuse, this is the opposite, so I'm going to use sine. So we've got sine to the minus 1, sine to the minus 1, opposite, which is r over 5r. The r's cancel, becomes 3 over 5. So sine to the minus 1, 3 over 5. Equals 36.86. So the angle that we want is double that. 2 times 36.86 is 73.7 degrees to 1 decimal place. There we go. ABCD is a parallelogram. So let's draw it. Sorry, it's a trapezium. Something like that. A, B, C, D. They always go around in order. So A to D is minus 2, 3. D to B is minus 1, 7. And A to B to B, I've got D to C, so I can work out A to B. So to get from A to B, I go from A to D, and then add D to B. So A to D is minus 2, 3, D to B minus 1, 7, so that's minus 3, 10, and D to C says it's 3 times that, so it's 3 times minus 3, 10, which is minus 9, 30. Then it wants us to find the magnitude of B to C. So B to C we need to go minus 1, 7 plus D to C minus 9, 30, which is 2, so 1 minus 9, which is minus 7, minus 7 plus 30 is 23. And the magnitude of that is the square root 7 squared plus 23 squared. Doesn't look right. Oh, I've gone wrong at the beginning again. A to D, which is in the opposite direction, so it's minus that, which is 2 minus 1, which is 1, minus 3, which is 4. Shame. So D to C is 3 times that, which is 312. So then B to C is minus 1, 7 plus D to C, which is 3, 12, which is 2, which is 5, 4, 5. And the magnitude of that is 4 squared plus 5 squared, which is square root of 41, which is 6 point, exact magnitude, exact square root of 41. There we go.